Binomial expansion and Pascal's triangle. So if you can understand binomial expansion and use it, then it tends to be an easy 6 or 7 marks in the exam because it's quite a long question, but there's a formula that goes with it. So just have a look at what the binomial expansion actually is, and then have a look at the formula and just understanding it, what it actually means. So in this case, what you're doing is you're doing in 2 terms binomial. That's where the bi and the 2 come from. So if you had a plus b to the power of 0, it equals 1, because anything to the power of 0 is 1. A plus b 1 to the power of 1 is just a plus b squared. You factorise it out quadratically, and then in the higher ones you just keep timesing by another a plus b, and you get this, and you start to see almost a bit of a pattern emerge. You've got a squared b plus an ab squared, a cubed b plus a squared b squared, ab cubed, a to the 4b, a cubed b squared b to the cubed, ab to the 4. And you see the coefficients on opposite halves of the binomial expansion are kind of the same. So if we take it for a general term, a plus b to the power of n, and we carry on the pattern that we're looking at, then what we have here is we have n1. That's not n over 1, that's known as n choose 1, and we'll come back to what that means in a minute. But the next term is the same thing, but instead you've got n choose 2, and all the ones that you had in this term change for a 2. And you're subtracting 1 from the a power each time and adding 1 onto the b power each time. And that gives you the general result, n r an minus r b to the power of r. And if r's n, so if you carry it up all the way to the end, then you've got n, and a to the n minus n, which is a to the 0, which is just 1, b to the n, and n choose n is just 1, so you'd have a to the n up this side and b to the n at the far side, like so in here. So this nr is n choose r, and you can find what the value of that is, so what 5 choose 3 is, or 6 choose 1 is, by using this little key on the calculator. You'll see like a big C, usually somewhere on the right hand side, that you might have to use the shift key to access. I can't remember for certain, but if you can just use that thing, find out what it is on the calculator, then you can calculate any of these values, and these values give the coefficients of each term in the binomial expansion. So the first term here would be 5 choose 1, 5 choose 0, then 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. You can't go beyond the limits of 5 and 0, it won't return a value. This coefficient part kind of links into Pascal's triangle a bit. Just have a look at it. So you saw on the other side we had 1, and then the coefficients of 1 and 1, then the coefficients of 1, 2 and 1, 1, 3, 3, 1, and so on. And these relate to Pascal's triangle. It's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And the way Pascal's triangle works is you add up the 2 terms to the left and right of it above it. So here you've got 1 plus 2 is 3, 5 plus 10 is 15. But if we look at how it relates to the choose function, so 1 choose 5, then we're just going to shift everything over to the left, so it kind of becomes a right angle triangle on this side instead, like so. And we then plot a kind of grid on it. And what we see here is each column and each row we give a number to, and we call this row the rows R and the columns R and the rows N, and NR if you use the choose function, so like 6 choose 2 you get 15, 8 choose 4 gets 70, and that's just a nice little representation of what the choose function is actually doing in regards to Pascal's triangle. You don't need to know it, but it's useful to know. Thank you for listening.